In this video, I'd like to go over how to use the standard normal distribution or the z-table for some very basic examples. Alright, so the standard normal distribution or the z-distribution is for a normal distribution where the mean is 0 and the standard deviation is 1. So our random variable z will be a value along this horizontal axis, and the shaded part under the curve will be the corresponding area or probability to the left of that z-score. So let's start with finding the probability z is less than 0.70. Sorry. So the first thing you want to do is you want to sketch what is given. Since the letter is z, I know I'm working with standard normal. So I want to draw a bell-shaped distribution with a mean of 0 and pretend that is symmetric. And I need to place 0.70 on this curve. So because 0.70 is positive, I know that z-score will be above 0. And it's going to be reasonably close to 0. In other words, it's not going to be out in this tail. Now this is a visual aid. I'm probably not sketching this exactly correct, but the important thing to keep in mind is where is z placed on this horizontal axis? Is it above 0? Or below 0, reasonably close to 0, or is it far out in a tail? So this less than indicates that I want to shade to the left. So this shaded part will be the area, which will also be the corresponding probability of getting a z-score less than 0.70. Now, unlike the discrete case, this is a continuous distribution, meaning that our random variable z can take on any value along this axis. So the case of equality doesn't matter in the continuous case, unlike the discrete case. For example, whether or not you included the value would make a difference in your final answer. In this situation, it does not. So looking at my z-table, it has 2 pages. The first page is for when z is less than 0. Now clearly for my example, z is above 0, so this is not the page I want to be on. So turning the page, and most textbooks have a pull-out z distribution, 2 pages, one for when z is below 0, one for when z is above 0. So I want to go to the page where z is above 0. The z-scores are along the outside of the table. The units and tenths place is the first column, and across the top will be the hundredths place. And inside the table will be the cumulative areas or the probabilities. Cumulative meaning we're shading to the left of z. So I want to find down, read to a z-score of 0.70. So I'm reading down to 0.7 and then over to the hundredths place, which would be 0.00. So you could think of this as 0.7 plus 0.00. Together that forms the value z equals 0.70. So the area from the table or the probability is 0.7580. And you want to make sure, does this make sense with respect to the problem? Well, since z is above 0 and the total area under this curve is 1, and the bell curve is symmetric, even though you couldn't necessarily tell from my sketch, 50% of the area will fall between negative infinity for a z-score up to 0. So I know my final answer has to be above 0.5. Sketching what is given or what is asked definitely helps with respect to does your answer match what's being asked. Now let's find the probability that z is less than positive 1.67. All right, again, I'm above 0, so I want to sketch something reasonably bell-shaped. My best interpretation of the standard normal distribution, putting 0 in the middle. And the inflection points where the curve changes concavity, meaning it's concave down, and where it's concave up for a normal distribution, happens at one standard deviation above and below the mean. So that gives me a sense of where this is going to be placed, although my sketch isn't very good with respect to indicating concavity. I do expect this z-score to be about here. And again, because I have a less than situation, I'm shading to the left. Again, I expect my final answer, my area or probability, to be greater than 1. I'm sorry, take that back. I expect that area to be greater than 0.5. Area or probability can never be greater than 1. My apologies. So going to the correct page where z is above 0, I'm looking for 1.67, so I have a 1 in the units place and a 6 in the tenths place, so I have 1.6. And then I need to read over to 0.07. And it's a little tricky, the print is somewhat small. So a z-score of 1.67 is right here, and that cumulative area to the left of the z-score is 0.9525. Okay, so this area is 0.9525. And that makes sense with what we expected. We expected an area or a probability greater than a half. Now let's take a look at some negative z-scores. Let's find the probability z is less than negative 2.83. Now this would be considered an unusual z-score. This is definitely below 2 standard deviations of the mean. So this z-score would be far out in the tail on the left side, and because it's negative, it will be below 0. So I'm going to put my z-score right about here. And again, I'm finding a less than, which is how the table reads. It reads cumulatively from negative infinity up to the z-score, and I want to find this area. I expect this area or this probability to be very small. Now, one thing to keep in mind is that a z-score can be negative, but area or probability, what you shade under this curve, can never be negative. It's going to be a value between 0 and 1 because this is a probability. So looking at my standard normal table, if I can get to the right page. I want to look at the first page and note that z is negative, and the z-score that I'm finding is negative 2.83. So I want to read down this first column to negative 2.8 and over to 0.03. So I have an area or a probability of about 0.0023. A very small area in that tail. So that is also the same thing as saying the probability of randomly selecting a z-score that is less than negative 2.83 is 0.0023. Okay, let's do one more. Let's find the probability that z is less than negative 0.18. So again, I'm given a negative z-score, so that z-score will be placed below 0. and that's a terrible bell curve, my apologies, but it's somewhat close to 0. So I'll put it about here. Again, because I have a less than, I am shading to the left, and that is exactly how our table reads. And because I am below 0 and I'm shading an area that is smaller than this left half, I expect my area or my probability to be less than 0.5. So going to my standard normal table, reading down to, and this is a little tricky with all my wires on my desk. Okay, I've got negative 0.1 right there, and then I need to read over to 0.08. Okay, so negative 1 intersecting with this column 0.08. I get 0.4286. And that is consistent with what I had expected. I expected an area or a probability less than 0.5.